Hi, in this tutorial we're going to discuss the coagulation cascade. This is a sequence of interactions between proteins to cause fibrin deposition at the location of tissue injury. There are two pathways, the intrinsic and extrinsic pathway. We'll look at the intrinsic pathway first. The intrinsic pathway is less important for initiating coagulation than the extrinsic pathway. However, the intrinsic pathway is very important for the amplification of the cascade. So let's look at what's involved. These pathways consist of a number of proteins called factors activating one another. These are usually denoted by Roman numerals. And the first factor of the intrinsic pathway is factor 12. The intrinsic pathway is also known as the contact pathway. This is because factor 12 can be converted to its active form, factor 12A, when it comes in contact with negatively charged surfaces. Most commonly, this surface is glass within a pathology lab. So as you can see, the active versions of these factors are denoted by the letter A. In this case, the active form of factor 12 is factor 12A. Now factor 12A causes the conversion of factor 11 to factor 11A. Factor 11A then in turn converts factor 9 into factor 9A. Factor 9A then converts factor 10 into factor 10A, but it does this with the help of factor 8A, which has been created from factor 8. Factor 10A can then convert prothrombin to thrombin, and it does this with the help of factor 5A, which of course has been produced from factor 5. Thrombin then converts fibrinogen to fibrin. Fibrin forms a mesh at the injury site to help produce the blood clot. Now let's look at the extrinsic pathway. This pathway is much simpler, and it is the pathway which is most important for initializing the coagulation cascade. It begins when a protein called tissue factor is released from damaged tissue. Factor 7 is converted to factor 7A, and then tissue factor and factor 7A combine to convert factor 10 to 10A. The pathway then continues on like the intrinsic pathway until fibrin is produced. One last thing we need to consider is the positive feedback effect thrombin has on the cascade. Thrombin has a role in accelerating the production of factor 11A, factor 8A, and factor 5A. In this way, the cascade is amplified to produce the necessary fibrin in a short amount of time. And that's an overview of the coagulation cascade. In the next haemostasis tutorial, we'll look at the drugs that can modify the formation of blood clots and thrombi. If you've enjoyed this tutorial, please help us produce more by making a donation at www.handwrittentutorials.com.